In a circuit lab, you're given 3 light bulbs, each with a resistance of R and a battery with a voltage of V. So both these batteries are V. We have R, R, and R. R, R, and R. In terms of R, find the total resistance of configuration number 1. And so what I'll do with configuration number 1 is I will combine these two guys, which are in parallel. And so I have 1 over R B in parallel with C is equal to 1 over RB plus 1 over RC. So 1 over RB in parallel with C is equal to 1 over R plus 1 over R, which is 2 over R. And so RB in parallel with C is R over 2. And so now what I have is a circuit that's equivalent, but looks like this, where this is equal to R and this is equal to R over 2. This is a series circuit, so I just add these together, and so our total for configuration 1 is 3/2 R. This one's a little bit tricky. They want to know which one has a greater current going through bulb B, figure 1 or figure 2. And so my logic here was to first figure out what the current is in figure 1 in terms of V and in terms of R. Recall that the total resistance of figure 1 is 3/2 R, and the total voltage is V, and so the total current, which is V total over R total, is V over 3/2 R, which is 2V over 3R. That's the total current coming out of the battery, total current going through A, but then the current splits between B and C, and it splits equally because those two resistors are equal in value. And so the current going through bulb B in figure 1 has to be equal to 1/3 V over R. Now let's look at figure 2. In figure 2 we have a parallel circuit, voltage V, and so we know that across both of these combined we also have a voltage of V. These two resistors would split that voltage equally because their values for their resistance are also equal. So I know that if I do VB equals IB RB, the voltage drop across B is V over 2. I'm looking for the current through B, and the resistance of B is R. And so the current through B is 1/2 V divided by R. You can see that is a greater current than going through bulb B in configuration number 1. Now we're supposed to rank the bulbs according to their brightness in figure 1, with 1 being the dimmest and 3 being the brightest, and using equal numbers if they are equal. So I'm going to think brightness depends on power, and power could be equal to I times V, or power is equal to I squared R, or power is equal to V squared over R. And we have to be careful about which one of these 3 equations we're going to use to evaluate which is the brightest. I think for this circuit it's easiest to think about currents. We have the total current passing through A, and then it splits between B and C equally. And so they all have the same resistance. If I look at this equation, since R is the same for all of them, I can clearly see that the bigger the current, the bigger the power, the brighter the bulb will be. And since A has all the current going through it, it's going to be the brightest, and then B and C each have half of that total current, so they will be equally bright but less bright than A, so I'll give them both a 2. It would also be okay if you gave them both a 1. We know what you mean. As long as B and C have the same number and that number is smaller than A, then I think you're in good shape. If bulb A were to burn out in figure 1, we would end up having an open circuit. And since we don't have a closed loop from the positive terminal of the battery to the negative terminal of the battery, no current would flow. So I think the important points here are that you write that I would equal to 0 through the entire circuit because we have no closed loop from the positive terminal to the negative terminal. If that's the case, then both B and C would be completely off. In figure 2, it's a little different. If A burned out and that was an open circuit, we still do have a complete path around the circuit. In fact, the voltage across BC would still equal to the voltage of the battery. The resistance of B would still be R. The resistance of C would still be R. And so when we think about power equal V squared over R, nothing has changed for those light bulbs. And so they'll remain equally as bright. Because the voltage has not changed across that branch. And the resistance of each bulb stays the same. So P, which is equal to V squared over R, does not change. And power is directly related to the brightness.